Hey everybody, this is Michael, and this is the Systems of Human Performance podcast, episode number 6. Yesterday I posted an article. It's not my traditional weekly article that I post, but it was kind of a special superlative one, and it's on billionaire Palmer Luckey. So I was not familiar with Palmer Luckey as of just a couple months ago, but I was cruising the web and I found some of his talks, and I really resonated with what he was saying. I liked how he approached a lot of the problems he was facing, and I wanted to dedicate at least a short article. I think it's only about a 4 or 5 minute read that I wrote here, but I wanted to dedicate a short article on why I liked his mindset and why I resonated with what he was saying. So what I'd like to do in this podcast as well is just kind of go through this article as well as look at some of the videos that I have embedded in the article to really break down, dissect, add commentary to what Palmer is saying from a systems thinking and system design view. Because I think if you're familiar with systems thinking at all, if you regularly read this Substack, you're going to see a lot of the same themes that we talk about coming to life in kind of this very high intensity application of being a defense product company or a defense contractor. So before we dive into it, I would always appreciate if you would like, subscribe, leave a comment, do whatever you can to help me boost in the rankings, as well as do yourself a favor and get notified when this podcast drops again. So thank you for that, and we'll go ahead and get started. So as I mentioned in this article, Palmer Luckey, somebody who I was unfamiliar with, he's already made several billions of dollars, mostly through developing the VR technology Oculus Rift and then selling it to Facebook, now Meta. And then since then, he's gravitated away from VR a little bit. He still uses VR in a lot of his products, but now he's in this domain of creating defense technologies. And he has a really, still very forward-looking idea of defense technologies in terms of VR and artificial intelligence and kind of all of these new materials that we're developing as well. But he's also using lots of lessons from history to guide him in what he's doing. And it's radically different from what the other defense contractors like Lockheed and the others, Northrop and all these others are doing. And I'd like to play the clip now, picking it up here at about the 27-minute mark. He's having kind of a sit-down conversation on stage with somebody from the Free Press. And just listen to what he's saying through the lens of systems thinking and how radically different it is from how we typically think about our defense sector right now.
Do that very, very quickly. And then the last thing that I'll say is we forgot one of the most important lessons of World War II. Everyone talks about how we made our weapons in automotive factories, in agricultural implement factories. John Deere made a whole bunch of tanks, and so did Caterpillar. And we also made to pivot our industrial machinery apparatus to doing this. Even our food service equipment industry, we pivoted towards this. Home appliance makers, everything. But what people forget is that we actually specifically designed weapons so that they could be manufactured by those existing workforces, existing machines, and existing factories. We're talking very tight design requirements that...
So I'll leave it right there for a moment. Really, really great takeaway, right? Is he's using these lessons of World War II to elucidate how he's going to approach defense products. And one of the things that he comes up with, one of the main ideas that is guiding his new defense company, I think it's called Anduril, is that defense and manufacturability and capability to manufacture are all very tightly coupled, and we can't get around that. If we cannot manufacture at scale some of the weapons that we have created on paper or in very bespoke and highly kind of laboratory environments, then it's really not worth anything, right? If we can't build a particular missile or something like that, if we can't build 1,000 of them very, very quickly in the case of an existential crisis with one of our foreign adversaries, well, then that missile really shouldn't be used as part of our defense strategy. So it's a guiding principle that Luckey talks about, and throughout all of these interviews and whatnot, it really comes to light why this is important. So I'm going to continue playing. We just caught the end clip. He was starting now to talk not about the manufacturing capability, but now specifically limitations of the manufacturer capability, which I think is also a great point that we'll come back to.
Drove the design from the very beginning. People would ask questions like, what radius can we bend that gauge metal in that particular Kenmore factory? How thick of steel can we heat treat in this existing automotive plant? What size of castings can we do? And to what level of purity? And those very specific engineering limitations on the manufacturing side are what drove the designs of our bombers, of our fighters, of our tanks. In other words, we designed weapons so that they could be manufactured by the industrial base that we had, not the one that we wished we had.
So again, really good rhetoric from Palmer here as well. What he's getting at in the realm of systems thinking, we would call theory of constraints, right? Which is any process is only going to go as fast as its slowest point. It's the principle of the chain is as strong as its weakest link, right? If we're going to try to create these marvels of technology to build missiles and fighter jets and stealth bombers and all of these other things, but if we can't build them consistently or quickly enough to actually compete with our international adversaries, well, then they're really not worth anything, and our system is going to fail when it starts to get stressed. Right now, we're building these things in peacetime, and of course, we're not stressing that system. But we need to prepare, and indeed, that's the point of defense, right? Is to prepare for conflict in such a way as to make ourselves capable when that conflict arises. So again, theory of constraints is coming through very, very strong here. One of the other big things of theory of constraints is that we shouldn't try to optimize locally. If we think of a manufacturing plant, which is the typical example, right? I can't, if my warehouse only has so many places to store materials, even if my upstream processes of producing these widgets exceeds that, right? I'm still going to be bound by what my warehouse capacity is. So I shouldn't be running my production lines 24/7 because I'm going to be constrained by a bottleneck process downstream. In a similar way, that's what's going on here, where we're optimizing locally, but we're optimizing all the way back in the design phase, where we're saying what's the absolute best that we can design this missile in terms of aerodynamics and performance. But we lose sight of what are we actually able to do downstream in terms of manufacturability, in terms of molding steel or folding steel, in terms of actually designing that in reality. So I think that's a very, very strong case to be made that Palmer is doing an excellent job of conveying. So I'm going to play this clip a little bit longer now. He's going to talk about a couple other things now, especially the benefits of what we gained in World War II from having this mindset of the industrial base feeding our defense base.
And that limitation worked great in two ways. First of all, it allowed us to ramp up very, very quickly. Two, it meant that after the war, all the machines that were making our war machine were instantly useful for actual normal things. We had a huge surplus capacity of car building capacity, or agricultural implement capacity. That's why cars were cheap post-World War II. People often credit it to the fact that our economy was doing well and everyone else is in shambles. Well, how about the fact that we had hundreds of bomber factories that were all of a sudden able to be turned into making automotive components, parts, and full automotive assemblies?
So again, just a great point there that I really appreciate him saying is, look, we're not trying to be a defense or a military country, right? We want to be able to pivot in and out of peacetime as quickly as possible. And one of the ways that we do this is by leveraging our existing industrial and manufacturing base. That allows us to ramp up quickly in the case of conflict, but then also ramp down quickly and move it back into peacetime industries.
I'll end my point here. One of the mistakes we've made is not designing weapons to be made by existing U.S. industry, but instead designing weapons that can be made by what engineers know is possible in the ultimate limit with unlimited money and unlimited time, where we're not fighting an existential war for our survival or the survival of our allies. You cannot make an F-35 in a Ford F-150 plant. And it was never intended to be. Nobody ever thought, maybe I should think about what I'm going to need to do if I need to make 100 times more F-35s. You're not going to make 100 times more F-35 plants. It's just not possible. You can't do it. And so this has been something I think Anduril's been doing right, and other companies have been trying to do as well. We're building things like torpedoes and submarines and cruise missiles that are designed to be manufactured by the same robot arms, the same plasma cutters, the same laser cutters, the same milling machines, the same staff and personnel that are currently making Ford F-150s and washers and dryers and, well, not those anymore. Those are all made in China. But they're at least making Ford F-150s. And I think that that's actually going to be key for us, because it's not just something we need to do for ourselves so that we're able to pivot our peacetime capacity into wartime capacity and back and forth, vice versa. We're going to have to figure this out for our allies around the world too, because they don't have real wartime capacity. We need to get very good as engineers at looking what kind of industry our various partners have and then building weapons that they can make. Is a country good at making carbon fiber bicycles? All right, let's try to figure out how to make a cruise missile that can be pressed out in one piece by the same composite press that's making those hot press carbon fiber bicycles. Oh, that makes it a little bit too short. You wish that you could have double the pressure? Too fucking bad. This is what the machine they have. They have 10,000 of them, and you're going to make it so it can be made out of that machine. And that was a hard restriction we used to understand. And as we fell out of existential fight for our lives towards kind of quasi-peacetime jobs program, we forgot why we were doing that in the first place.
So an excellent job of really juxtaposing this idea of local optimization. Hey, we built this F-22 on paper, even though we can't make it in anything less than kind of a laboratory setting. And then applying this principle, not just to ramping up and ramping down in wartime, but also leveraging that to our allies, understanding their industrial capabilities and what can be leveraged there to build up kind of an ecosystem of this highly capable, highly manufacturable defense arsenal. So I think it's a great example of this theory of constraints coming through in a big way, as well as showing the downsides, the real downsides of local optimization, starting with that design. I'm going to go down a little bit further, and I have this other TED Talk that I've put in there. He's talking about similar things, but also different things as well. And I'd just like to play this as well. It gives you a little bit different flavor. Again, he's talking a lot about the capabilities, both in terms of the design of defense weapons, as well as the capabilities of the manufacturability. And again, this is why I like how Palmer is talking about these things, is he understands that this is a system. He understands that these two things, as much as we might like to treat them separately, they're extremely coupled together, right? We cannot design in isolation and then try to manufacture in isolation. Anybody who's worked in manufacturing or industry at all knows that this is this is a reality that you cannot get around, right? Is if the designers and the manufacturers are not talking, we're going to run into lots and lots of problems, lots and lots of cost overruns as well. So again, now a TED Talk, different form. This is what this is what Palmer Luckey has to say as well.
So how do we do that? For centuries, military power was derived by size. More troops, more tanks, more firepower. But over the last few decades, the defense industry has spent far too long handcrafting exquisite, almost impossible to build weapons. Meanwhile, China has studied how we fight, and they've invested in the technologies and the mass that counter our specific strategies. Today, China has the world's largest navy, with 232 times the shipbuilding capacity of the United States, the world's largest Coast Guard, the world's largest standing ground force, and the world's largest missile arsenal, with production capacity growing every single day. We'll never meet China's numerical advantage through traditional means, nor should we try. What we need isn't more of these same systems. We need fundamentally different capabilities. We need autonomous systems that can augment our existing manned fleets. We need intelligent platforms that can operate in contested environments where human-piloted systems simply cannot. We need weapons that can be produced at scale, deployed rapidly, and updated continuously. Mass production matters. In a conflict where our capacity is our greatest vulnerability, what we really need is a production model that mirrors the best of our commercial sector, fast, scalable, and resilient. We know how to win like this. We rallied our industrial base during World War II to mass produce weapons at an unprecedented scale. It's how we won. The Ford Motor Company, for example, produced one B-24 bomber every 63 minutes. But to actually achieve the benefits of these mass-produced systems, we need them to be smarter. This is where AI comes in. AI is the only possible way we can keep up with China's numerical advantage. We don't want to throw millions of people into the fight like they do. We can't do it, and we shouldn't do it. AI software allows us to build a different kind of force, one that isn't limited by cost or complexity or population or manpower, but instead by adaptability, scale, and speed of manufacturing.
So I'll pause it there. I think the whole TED Talk, and there's a subsequent Q&A where Palmer gets really in the weeds of what he's actually envisioning, and I encourage everyone to check it out. But right there, I think he's got a lot of good nuggets there that really underlie his systems thinking approach to the problem of defense manufacturing for the U.S. And he's talking about kind of this up and coming adversary with China. He understands that from a numerical advantage, we're at a huge disadvantage, or excuse me, from a numerical position, we're at a huge disadvantage. He understands that in order to counter that, we need to be looking at new capabilities of the technology, but that also need to be leveraged and produced at scale. So one of the things that he gets to, he didn't talk about it necessarily in that particular clip, but if we can use all of this technology of AI, it means we can actually make maybe not fighter jets, maybe not F-22s, but we can have all kinds of assistance that could fly with an F-22. So imagine you have 5 unmanned fighters for every one F-22. You go into a dogfight and you can sacrifice any one of those 5 AI unmanned vehicles, aerial vehicles, to save the F-22 fighter and also to destroy your target. So it's a really interesting idea, a really interesting paradigm that he's getting at. I think he's one of the only people who's talking about it in this way. I think he's right on the bleeding edge of all of this. And it's really, really cool to see this idea of systems thinking coming through and being applied right on the cutting edge of technology, of defense products as well. And I wanted to end this article by looking at one of the ways that we used this strategy of kind of manufacturability and defense capability in World War II as well. So as Palmer Luckey was saying, of course, we leveraged our own our peacetime industrial capability in Ford manufacturing plants and John Deere factories and Kenmore facilities. But we also had that paradigm in World War II on the attack. There's this famous operation, it's called Operation Point Blank, and the purpose of it was before D-Day, before we landed in Europe, we tried to hamstring and really disrupt the industrial capability of Nazi Germany as much as possible. And one of the ways that these engineers and military folk who were designing this operation pointed out was that all of Germany, all of the Wehrmacht of Germany, of the tanks and the Luftwaffe, and all of this, really, there was a single point of failure that was, if this point broke down, they couldn't continue producing tanks, they couldn't continue producing fighter jets or bombers and any of these things. And that one single failure point was ball bearings. You need ball bearings for tanks and military jets and personnel carriers and artillery and all of these things. And if they could just bomb a couple ball bearing facilities, that's their industrial capacity, their industrial capability, the entire war machine of Germany would come to a halt. So again, it's a great application of systems thinking. It's that bottleneck theory, right? Is that we can only go as fast as our smallest part of the process. The chain is only as strong as the weakest link. And if we break that link, in the case of Operation Point Blank, where we bombed out all of their ball bearing plants, that means that that industrial capacity cannot be leveraged. You have all of these tanks sitting in the warehouse that can't move because they don't have ball bearings. And you gain a huge strategic advantage by applying the principles of theory of constraints to your strategy in wartime. So again, a fun, cute little article. It's about 4 minutes long if you want to read it. I also highly encourage you to watch that entire TED Talk, as well as a lot of the different clips that I pointed out in that Free Press talk. So again, I really was tickled when I started hearing Palmer Luckey. I'm going to be checking him out often, and I'll probably have another article come out as I see new content coming from him. So again, I really appreciate you tuning in to this short little podcast here, just coming up on 20 minutes. If you would, please like, subscribe, leave a comment, do whatever you can to get notified of this podcast, but also to help us out in the rankings. Thanks a lot.